Hello, my name is Yuki Onishi from Tohoku University. I will present self-actuated stretchable partitions for dynamically creating secure workplaces. I did this project with Kazuki Takashima, Kazuyuki Fujita, and Yoshifumi Kitamura in Tohoku University, Japan. Many people spend a lot of time in a particular office environment. In the office space, the different work settings are selected based on work activities. To manage various work settings within a limited physical space, Office requires a layer flexibility. Therefore, dynamic optimization of spatial configuration is necessary. For separating the office for small parts, physical partitions are mainly used. Physically partitioned office is especially secure against protecting personal privacy and decreasing of infectious risk. So, we try to create secure workplaces with dynamically actuating partitions depending on the situations. Some of the works have already considered flexible actuating partitions. The one approach is virtually partitioned workplaces using AR, but this is not physical wall, so visual privacy is still exposed and cannot protect virus infection. Another approach is independently controlling the transparency of 2D array of controllable pixels. But this programmable window is static and lack of mobility. The right one investigated psychological effect of behavior of robotic partitions approaching movement, but this partition has lack of vertical shape-changing freedom. From these works, we decided to design physical actuating partition, which has mobility and shape-changing functions. This is our proposed self-actuated stretchable partition. Our partition's height and length are adjustable, which offers multi-types of spatial configurations to support individual and group work. In addition, the partition automatically moves and rotates by actuator, so it can be placed anywhere. Here is a system detail of proposed partition. The partition's height is changeable with height adjustable stand switching up and down by Arduino, and the partition is carried by actuator. With this prototype, we designed practical applications to explore how self-actuated stretchable partitions can arrange a space and dynamically create secure workplaces. The first application is Individual Workplaces Builder. For separating the individual workplaces, when the system detects that coworker sits on the next desk, the partition raises itself automatically. The second application is Informal Collaboration Supporter. For flexibly switching between individual and collaborative workplaces, the partition falls to open the user's perspective and create the open space. Another application is Adhoc private spot. When detecting a situation that requires to protect a user's privacy, partitions gather towards the user and create a personal spot around him. After finishing the task, these partitions break up again. The last one is guidance applications of keeping distance among people. The partitions automatically approach to the middle of the users and adjust each standing area to preserve greater social distances. To conclude, we propose self-actuated stretchable partition to create privacy and infectious risk secure workplaces. We design practical application realizing secure workplaces. As a next step, we design an interactive partition arrangement tool and then validate the level of secure. We also explore scalability and flexibility with a large number of partitions. This is the end of my presentation. Thank you very much.